Annyeong everyone, welcome to Math with Miss Kim. Today we are going to learn about one-step equations, specifically when we have subtraction. Before we get started, I want to shout out Javier and Tony. They were consistently completing the assignments last week and were uploading them by the deadline every day. So I want to give a shout out to those two. Well, let's get started. So again, with these lessons, you want to have something to write with, and you will see that I am also taking notes right alongside with you all. Let's begin. Here is our first equation. We have x minus 12 is equal to 4. Well, here is our keynote for this lesson. So equations written in this format of x minus p equals q, they can be solved by adding p from both sides. Just a quick refresher about the term equation. Here is a little note. So an equation is a mathematical statement that two expressions are equal, and that is indicated by our equal sign. So looking at our equation, let's go ahead and see if it matches up with our keynote. So if we look here, we have an x here and we have an x up top. This is our variable. So I'm going to label my variable with an x. Here in our keynote, it says x minus p. Let's see if we find the p. Looking up here, I'm looking for a number being subtracted from our variable. Here it is. So this 12 plays the role of minus p. And now we see, okay, the q in our keynote is alone, and the 4 over here is alone. So the 4 plays the role of our q. Well, our keynote tells us that we can solve for our variable x if we add p from both sides. So we know that 12 plays the role of p, so let's go ahead and add p on both sides. So I add 12 on this side of my equal sign, and I add 12 on the other side of my equal sign. So I now have x is equal to 4 plus 12. That leaves x as equal to 16. This is the solution to our equation. Well, going back to the title page, I labeled this as a one-step equation. And you might be wondering, what does that mean? So here's a little note about what a one-step equation is. So a one-step equation is an algebraic expression that you can solve in only one step. And the equation is solved when the variable is alone. So we were able to solve this equation using just one step of adding 12 on both sides to get our variable alone. Well, solving it is not enough. And again, the brightest and best always check their work. So let's go ahead and check to see if x is equal to 16. Is that truly the solution to our equation? So again, the brightest and best always check their work. So when we solve this, we said x is equal to 16. That means I can plug in the 16 where I see the x. So let's go ahead and do that. So instead of the x, I'm going to write in the 16 because we said x is equal to 16. I will know if this is indeed the solution to my equation if both sides of the equal sign have the same value. Well, 16 minus 12, that's 4. So I see that both sides of my equal sign do indeed have the same value. That means x is equal to 16 is the solution to our equation. Well, let's go ahead and look at our second problem. So here we have g minus 4 is equal to 27. If we look here, this is a different letter for our variable. So your variable could be typically x, or you can use a different letter. So here we have g. Well, again, here is our keynote. Let's see if this follows the same format. We have our variable x, we have a variable g, so we have a variable. I'm looking for a number being subtracted from my variable, and I see that here. The 4 is being subtracted from the variable. So the 4 plays the role of p. And then q is by itself, same with the 27, so that plays the q. Well, my keynote tells me that I can solve this equation by adding p on both sides. So let's go ahead and do that. So we are going to add 4 on both sides of our equal sign. So we have g is equal to 27 plus 4. That leaves me with g is equal to 31. So we have our solution to our equation, but again, the brightest and best check their work. So let's go ahead and check to see, is this indeed correct? So we just solved that equation and got g is equal to 31. That means wherever I see g, I can plug in 31. So let's go ahead and try that. 31 minus 4 equals 27. I will know if this is a solution to my equation if both sides have the same value. 31 minus 4, 27. So I see that both sides have the same value. That means g is equal to 31 is the solution to our equation. We have one more problem. Let's go ahead and take a look. Here we have 33 is equal to v minus 9. And again, here is our keynote. Ooh, it doesn't really look like it matches this format, but let's go ahead and look at the individual pieces and see if they match. So, do I have a variable? I have a variable v. Remember, a variable could be any letter. It could be x, it could be t, it could be v, any letter. So we have our variable here, so I'm going to label my variable. Okay? Now I'm looking for a number being subtracted from my variable. And I see that here with the 9. The 9 is being subtracted from our variable v. So the 9 plays the role of the p. And then we have q by itself. We got 33 by itself. So 33 plays the role of the q. So our keynote told us we can solve this equation by adding p on both sides. And our 9 is the p, so we're going to add 9 on both sides. So now we have 33 plus 9 equals v. And 33 plus 9 gets me 42 is equal to v. And this is a solution to our equation. But again, we're going to check our work. So let's check to see, is this indeed the solution to our equation? Here was a problem we just solved. This is what we got. I should be able to plug 42 in for v and see if it works. So we have 33 is equal to 42 minus 9. I will know if this is the solution to my equation if both sides of my equal sign have the same value. 33 is equal to 42 minus 9. That's 33. we see that V does indeed equal 42. So this was a lesson on solving a one-step equation with subtraction, and here was our key note. Remember, x minus p is equal to q. Equations written in this format can be solved by adding p from both sides. Thanks for joining me today. I'll see you next time.